Okay everyone, if you've been following on from the previous tutorial, we have built out this little scene in Houdini. We have created some geometry, we just threw in an environment light. We quickly set up a renderer so that we can see what's going on. And this is where we currently stand. So now what we're going to do is we are going to create some materials and shade this, this image, give it some texture, give it some color, and I'll show you guys how to work with materials. And we are going to be building a procedural material. So before we actually start building the materials, what I'm going to do is let's just jump back to object level. Let's go to scene view, and here's our scene. We have our objects, got a camera, got an environment light. So what I'm going to do is actually just disable everything. So we have a blank scene. I'm going to come up to the top here and hit Command and then click on the sphere so that it creates a sphere at the origin. Here we go. And I'm just going to call this test material. And let's dive inside. Let's switch this to a polygon, and I will show you why. Let's give it 50 in the frequency, and then what I'm going to do is let's just transform it here. Let's go say 5, and then hit T to set up, to throw down a transform, and we can do that because we created our own custom shelf. And if you right click, go edit tool, this is where you can set the hotkey for that. And let's just transform this up, say 2.5. And actually what we're going to do is we're going to keep it at 1, and we are going to just transform it up. I'm just going to jump into the front view. So currently, if we just drop the frequency down to 2 again and hit W to go into wireframe, right now our sphere is sitting between 0 and 2. So what we want to do is let's just drop the radius back down to 0.5, 0.5, 0.5. And then let's, instead of transforming up 1, let's just go to 0.5. So you'll notice that our sphere, let's just bring the frequency up a bit. So now you'll see that our sphere is currently sitting between 0, the origin, and 1, which is what we want. So hitting spacebar 1 to jump back into the perspective view, hitting W to get rid of the wireframe, and let's just hit spacebar F to get nice and close. Okay, so now our object, our sphere over here is, let me just get rid of the lighting. It's sitting between 0 and 1 in Y, but you'll notice that it is still crossing the border into negative values over here. So it's probably sitting between positive 0.5 and negative 0.5. So just for the sake of this tutorial, what I'm going to do is let's just translate it forward by 0.5. And now our sphere is currently sitting, let's do the same for translate. You don't always have to do this, but for building a procedural shader, it's nice to have your object in 0 to 1 space. So if I jump back to the front view and hit W, you'll see we are 0 to 1 in Y, we are 0 to 1 in X, and then if I hit spacebar 4 and go to the right view, hit spacebar F just to get nice and close, you'll notice that in Z we are in 0 to 1 space as well. So this is good, and I will show you why we do this now. So just hitting W to go back to wireframe. What we are going to do is let's just give our sphere some frequency, set it to say 100, so that we have a nice dense mesh. And What I am about to show you isn't just for shading, but for a lot of things in Houdini where it comes into proceduralism. The position attribute is what we want to be using and manipulating, and instead of using UVs, so you'll notice that if I hit spacebar 5, we don't have any UVs, okay? Let's hit spacebar 1 to go back to perspective view. This is where the magic happens. So what I'm going to do is hit tab, type attribute Vop, and throw down a Vop. Now, this is an attribute Vop. Basically, Houdini uses Vops or the Vop context in many different areas. It is here in the object level, and once we get into materials, we are going to be using Vops as well. So Vops are vex operators. So instead of writing a whole bunch of code, we are just going to select the attribute Vop, hit enter, and dive inside. So now you can see we're inside of the attribute Vop. And we have two nodes here. This node over here is the global variables, and this is the output. So essentially, this node, these parameters are everything that is connected to this current geometry. So where it says P here, P is position, V for velocity, CD is color, UV, and normals. There's a whole bunch of stuff here, but for what we are going to do is essentially just play with the position. And there's a position over here. So let's just jump back up to the top because we're going to need some more points because this is all essentially point-based. Let's up our frequency to, say, 100. So now we have a nice dense mesh, and inside of the attribute Vop, I'm just showing you guys this now on the object level so that we can actually see it in the viewport. Once we get into shading, we are going to actually have to render things, and it just adds a bit of time. So this is quicker when you are just doing some look development for a potential material. You can see it all inside of the viewport, and it will speed up your workflow and just let you see things easier. So now that we are inside the attribute Vop, what we are going to do is just hit tab and type in turbulent noise, throw down a turbulent noise, and now what we need to do is the turbulent noise needs a position. Here's the input over here for position, and what we want to do is say wrap this turbulent noise around this object using the position. So if we take P for position here, plug it into the position of our turbulent noise, and now if we take this turbulent noise, the output, and plug it into CD, which is the color, we'll see we now have some noise in the viewport on our sphere, which is really cool. Just to demonstrate this a little bit more, or some of the cool things that you can do. So turbulent noise comes with a bunch of presets. There are other noises. For speed's sake, we're just going to stick with turbulent noise. But if you hit tab and type in noise, there's anti-alias noise, curl noise, Wally noise, unified noise, Veroni noise, and not all of these have a position input. So I will show you guys quickly how to manipulate UVs as well if you need to. So I'm just going to quickly adjust this turbulent noise so that we get a bit more out of it. Actually, the first thing we're going to do before we manipulate the turbulent noise, right now the values are pretty low. There's quite a smooth gradient running through this noise. So what we want to do is we want to come over here and hit tab and type in fit range. There it is there. Plug in a fit range, and this fit range is essentially a levels. If you've used Photoshop before, in order to get a bit more contrast out of your images, you might use a levels, and essentially what a levels does is just adjust the black point and the white point, and you can just get a stronger contrast. So if we just take our source min and bring it up a little bit, you'll see things get a bit darker. And if we take our source max and we bring it down, the whites should start to get a little brighter. So something like that should be cool. Let's flip through quickly and just see. So we have alligator noise, there's Perlin noise, which is quite a subtle noise. There's original Perlin noise, which has a lot more density and distance between values in it. There's sparse convolution noise, there is alligator noise, simplex noise, and then zero-centered Perlin noise. So if we disable our fit range, we'll be able to see those a little better. But for now, let's just keep it on, say, original Perlin, and let's enable our fit range again. So now we have this. And yeah, like I said, what this is doing is that it's looking at our object, and because our object is within a 0 to 1 space, it is taking the position and it is mapping our turbulent noise to our object, where we are then adjusting it, just getting a bit more contrast in it, and then we are plugging it into the color. So this is how we start to build some procedural shaders. It's all built off of this idea, and now we can start manipulating things. So one thing we can do, coming into color, there isn't really much color to this because it's just a noise. This is a float, and the position is a vector. So we'll probably get into that a little later, but for now you just need to know that there is a difference. The green over here are vectors, and the light blue or cyan is floats. So just keep in mind that you can't just go from a vector and plug it into a float. You first need to convert it. So to get back to our color, what we can do is just hit tab and throw down a ramp parameter and throw this down here. And now we get a RGB color ramp. So I believe if we change this, nothing's going to happen. There was no update, because what this ramp does, it actually promotes itself up to the top level. So if we jump up to our attribute Vop, here is our ramp parameter over here. So if we want to adjust the color, and it's quite handy if you start building things and just want to adjust the color inside of your object, not having to jump into the attribute Vop every time, it does get handy. So if we just select our color here, and let's make it say red, and where our white is, let's say it's blue. So there we have two colors. What we can do as well is just start adding colors. So maybe a yellow, that's pretty cool. And then over here, let's maybe get like a purple. Cool. So it's placing the color on the object relative to where this is, our ramp is. So it's going from 0 to 1. So if we jump into our attribute Vop and we start changing our fit range, the colors are going to change as well. And you can actually animate this stuff, which is really cool, on the object level. And then when you render, I will show you what happens, because it will just inherit the color. So the color is based on the 0 to 1 space, wherever this color is. We can also move these around. But instead of animating these, what you would need to do is, because inside of Vops, Houdini doesn't understand animation or time. There is a time like input here, which you can use, but to have full control, if you want to animate it, just take your fit range, and where it says source min, just middle mouse click on here and just go promote parameter. And let's do the same for source max. So now we have promoted it to the top level, and now we have our inputs and colors here. So now, with inside the object, Houdini understands keyframes and animation. So we can actually, what I'm going to do is just click Alt and then left mouse click in here to set a keyframe. And then let's just go to 24 frames and let's change this to 0.4 and then hit Alt and click in there again to set another keyframe. So let's just change this to 24 frames. And what I'm going to do is I'm just going to hit this button, which is the real time button. So it's going to play at 24 frames a second. And let's hit play. And we can see we are now animating the color of our object, which is pretty cool. If we didn't have this checked, it will probably go a lot quicker, but I am recording, so things are pretty slow. Okay, so that's just a quick little idea into animation. To delete this, just going to go delete channels over here. Now we have gotten rid of our animation. You might be wondering why we moved our sphere over, and that is because if we start moving this transform around now, our color isn't going to stick to our object. Okay, you see how we're moving this around and the noise is actually moving. That is because we haven't set a rest position. So I'm just going to quickly see if this works. And also, if I start moving this, say, downwards, we're going to start getting some negative values. So it's a little bit difficult to see, but to better demonstrate that, let's jump back into our attribute Vop. Now, to better understand this, what we're going to do is we're going to take our position. So our sphere is in 0 to 1 space, okay? So this is a vector. So what I'm going to do is I'm going to type vector to float, and we are going to convert this vector of our position to a float. So now we've taken the vector, and these outputs here, the first one is x, y, and then z over here. So if I had to plug the y parameter into our color, you'll notice that we get a ramp. Okay, we get a gradient from 0 to 1. So I'm just going to hit tab and throw down a fit range again and plug it in here. And then I'm just going to set this to say 0.49 and to 0.51. Instead of a gradient, we now have a nice tight center point. And what's going to happen is that if I start transforming the sphere around, you'll notice that our gradient moves, which can get quite tricky when you are procedurally creating things, especially shaders, is that, you know, we wanted a mask, or we wanted to cut our object in half, and if our sphere was still down at the origin, you'll notice that we wouldn't be cutting it in the right place. So that's why I moved the sphere over to positive 0 to 1 space, so that I have a true representation of where I am creating things. So you might say, well, I want to be able to move my object around and it will keep the color. What we are going to do is, let's just throw down another transform after the attribute Vop. And I believe if we move this up, now everything, or move this down, it keeps the color, because we are now transforming the object after we have procedurally added our color. Cool. So if we throw down a transform after here, then we can move it and everything will stay the same. So let's jump back into our attribute Vop, and this is really handy. Using the position pass in order to create masks and mats and layer blends, it really it goes a long way, and I'll show you that a bit more once we get into the actual shading. So, you know, say instead of the y-axis, I wanted the x-axis, I could plug that in, and now we have a mask like this, or on the z-axis we can do that. Cool. So this is the basis of procedural shading and procedural texturing. So, you know, this might look pretty straightforward, but what else can we do? So we now have this colorful ball over here that we've added a ramp to, and you know, you can only really get so far with one noise. So what we can do is, let's just duplicate this by holding down Alt and dragging. Let's up this frequency to, let's say, 10, 10, 10. And what we are going to do is then we are going to multiply this. So we can hit Tab, throw down a multiply, plug the multiply in here. So you're basically multiplying this value by whatever this value is. And there we get a bit more variation. So because this is still quite soft, let's just throw down a fit range over here. And just so that we can see it, let's just add it straight into our color. And that looks pretty cool. Let's just get a bit more contrast. Something like that. And then let's plug our ramp back in and multiply this again. So there we go. And now all you need to do is just play around with these frequencies, and you can create a whole bunch of cool, interesting colors, patterns, variations. There's a lot of awesome stuff that you can do. So we'll get into that when we start shading, which is going to be soon. The last thing that I want to show you here, just so that we can see it in the viewport, is that we can actually start manipulating our position pass. So instead of multiplying this in at the float value so that we get color, what I'm actually going to do is I'm going to take this turbulent noise, and let's just get rid of this for now. And now instead of adding it over here, what we're going to do is add it to our position. And let's have a look what that does. So let's type down add. Let's plug the add in over here. And then let's add this noise to the position. And if we just go back to our sphere, let's give it, say, 300 in frequency so that we get a better looking object. You can see now we have started to distort our color by distorting the position. And if we just disable that, you'll see now we get this cool fractal. We get this cool fractal. And again, you know, we can just adjust our values and we can start getting some really cool, really interesting shapes. And if I just disable this, you'll see we have gone from that, and now we have a bunch more detail and some cool looking patterns. So you might be thinking what this is doing. Essentially what we are doing is we are taking the position and we are distorting it. We are distorting it by this turbulent noise. And you can get some very, very cool things. Very cool variations. I won't go too far into it, but just play around, just throw in a whole bunch of different turbulent noises or other noises and start adding it in. So I think, you know, we can go to, let's pick another noise. Let's do anti-alias noise. Plug the position into the position. And then let's just plug this into our color for now so we can see this. So this is what our noise looks like. Let's go, okay. Let's not use an anti-alias noise because that's exactly what it is. It's just anti-aliased. Let's throw down a unified noise static. And the static version is just quicker to compute. So you'll notice that the position isn't up here. It's actually down here. So let's plug that position in here. And then let's plug our noise. Let me just get a little bit more space. And now let's plug our noise into the color so that we can see it. And the unified noise, we have to set it up. It's set to simplex. Let's just go with like a Wally cellular noise for now. Cool, let's up the frequency to say 10, 10, and 10. So we get these kind of blocky looking objects, this little cellular pattern. You can really just go to town on all of these parameters here. You can really have a lot of fun. So now instead of, let's just plug this back in so we know what our texture looks like there. And now instead of adding this noise, let's add this noise to our position and see what we get. Boom, check that out. Cool. So I hope you guys are starting to see the power of this setup, and especially that we can see it in the viewport. Everything's instant. It really speeds up your workflow. So this is cool, but you know, it's just kind of color now. You might be like, well, let's displace this thing and see what happens. So I'm just going to get rid of that. Now to displace the geometry, what we are going to need is a displace along normal, and we are going to plug our position over here. Oh, not our velocity. We want our position. I'm going to plug it into position. The amount in the displace along normals is going to come from this fit range over here. And then the, so let's plug it in. Let's see what happens, but I know it's going to go crazy. So now if we take this displace P and plug it into our P for the output, boom, craziness. Look at this. Okay. Whoa. So obviously this is not what we want. So what we're going to do is throw tab and let's type multiply constant, and we are just going to take this value. I think we can do it either way. And let's just take this down to say 0.05. And instead of plugging it in there, you can just shake it to get it loose, apparently. Or, okay, my machine is a little slow, so it's not letting me shake it. Oh, there we go. Okay, I shook it off. Or if shaking is a little bit too much, what you can do is just hold down Y, and it'll bring up these little scissors. And let's just cut that and cut this. And then we're going to plug our multiply constant over here. And then let's plug this back into our displace, our position, output position. So now you can see we have some displacement going. It's still a little crazy. Let's maybe take this down to 0.1. And you'll see that we now have some displacement. So if we plug this noise back in, you'll see that the displacement updates and it gives us a pretty nice result. Let's maybe get rid of this for now. Just because our values are quite choked at the moment. So let me bump this up to say 0.5. And there we go. Now we have displacement in the viewport along with our color. We can bring our values back in. and you'll see that we have some displacement. So this is essentially Vops. This is how we are going to do our procedural shading and texture building, and it's all built off of this concept. And once you kind of get the hang of this, and hopefully this helps you understand it a little bit better, what we're doing is we are looking at our object in a 0 to 1 space, so that we know when we are using our fit ranges and our position, we know that the middle should be 0.5, and we know that we are going to be able to apply color and textures to our objects based on their position, and we can manipulate a whole bunch of parameters. So yeah, you can really go nuts with this, guys. Like, you can get so many different variations, so many different looks. You know, it's pretty much endless. And ooh, we even got some more there. Let's maybe do this. And yeah, just have fun with it. So I usually only use this inside of a attribute Vop so that I can see what I'm doing. I can see the patterns that I am creating. And now what we are going to do is jump in and create a material. And instead of seeing it in the viewport, we are just going to start rendering it. Because the setup, there are a few little things that you have to change and do, but the principles are essentially the same. So we're going to keep the sphere. Let's just disable our attribute Vop so that we just have our sphere here. Actually, let me enable that. I'm just going to get rid of our displacement. So jump inside, hit Y, cut the wire. No more displacement, just color. Okay, so just disable that for now. And now let's jump into our material network over here, and let's start building our first material.